Hello everybody, so I want to show you guys a configuration and how to use a new service that the department is providing for all of you. It's effectively going to give you an isolated Linux sandbox as well as a graphical interface for VS Code. So what is the benefit of that? Every single week there's 5 to 7 students that will come by with a disastrous story, and it's obvious that it's completely true. It may range from like, hey, my instructor wants me to have this environment set up. I've not been able to get Linux on my machine. It's not working, or I installed it and now I've run Windows on it, or I can't boot either one of them. I'm seeing these grub errors. Other people bring in their laptop into pieces and saying, hey, I just broke my laptop and I need something for my class. Could you help out? If I've got a free computer, I'll loan them out. But at some point, after these disasters keep happening with the various students throughout the semester, we run out of spare laptops. And some of the laptops we got, they're not like the one that you had, but at least it would carry you over. So what this service will allow you to do is allow us to give maybe anybody that needs kind of a sandbox to get assignments completed or to play around on Linux, it's going to provide that for you. Now, it's not going to be identical to you having your own Linux machine, but it's going to be very close, and for all practical purposes, it will provide you with that. Okay? So, all of this is kind of brought to us in a really kind of amazing way using virtualized environments. So, I know this is not really necessarily in the thread of what I want to cover. I do want everybody to be conversational and like certain things. So, like, I know you got these exposures in other courses, but anytime we can offer exposure to where you're maybe more conversational in a job interview, or you can list on your resume that, hey, I'm aware I've got exposure to certain environments, that will be beneficial. So what I'd like to do is describe how this service is brought to you, and you'll be able to kind of maybe understand whenever you see me configure it on like I'm going to pretend like I'm a student logging in and configuring it. This will kind of lend itself to you. This will kind of lend a little bit of an explanation about what's actually happening. So let me transition to my notebook really fast, if you don't mind. So the AWS cloud is essentially a collection of data centers that are scattered all over the world. That's owned by Amazon. It stands for Amazon Web Services, and we all refer to it as AWS. It's by far the largest cloud provider that we have. Azure's kind of behind it, but I believe AWS is still the largest. So let's break it down to the United States. Let's draw like a quick drawing here of the United States. So in the United States, we have many AWS data centers. We have one that they call the US East 1 in North Virginia. We have US East 2 in Dayton or Columbus, Ohio. And then we have many more, but let's suppose we could have as far over here as the Oregon, the US West 2 data center. So what happens is sometimes you can actually just create services that exist in exactly one of these data centers. And occasionally you create services that will link up many of these data centers, so that way if a customer over here reaches out to your website, service, whatever, the load balancer will detect, hey, they're closest based on some sort of metric to this thing, so they'll actually be served from here. Whereas this person, whenever they access seemingly the same service, it's actually being served from here. And then you can create configurations where these things will sync up all the data that they're getting, reading and writing, databases, whatever. For our particular purpose of this service, it is located in the US East 1 data center in Northern Virginia. So in the US East 1 data center, you have this massive data center that AWS owns. One massive data center. And it's cool because I've got to see some of these in the past. It is remarkable at how much computing power is inside of these things. So inside of these data centers, up to a certain point, you'll see a whole bunch of these rows of servers, just row after row of servers. Okay, now inside of one of these rows, like maybe here, you'll see effectively collections of these giant racks. If you guys go to the second floor of Duthie, when you look at the top of the steps, you're seeing one of these. Sometimes these can be 7 to 8 feet tall, and they're roughly, 19 inches wide. And what you'll see is you'll see this thing filled from top to bottom with servers. Now, one of these servers may have like 2 terabytes of RAM or more. That's not even becoming uncertain. That used to be a whole lot. It's not even considered really all that big for data centers anymore. It could have many terabytes hard drive space. It could have hundreds of cores of processing power inside of it. And what they install on this server right here, what they install on this server is something called the Nitro hypervisor. So it has something called the Nitro hypervisor installed on it. Now, what this Nitro hypervisor allows to happen is we have one massive computer that's probably bigger than what maybe one person needs, or what the vast majority of customers will actually need. Because something that big could actually serve a whole lot of requests, varying from API calls to whatever. So what they actually do is whenever AWS, like whenever I fire up something, these computers, what seems to be like a server, can fire up in just a matter of seconds. And the reason for that is the Nitro hypervisor running on all these servers can effectively allow this server to be subdivided into what appears to be individual operating systems, to where they appear to be completely isolated, but they're actually running on one machine. So that's kind of cool. So maybe this operating system is Windows. Maybe this one is Ubuntu. Maybe this one is Red Hat. Maybe this one is Amazon's version of Linux they call Amazon Linux 2. And then maybe another one on here is running maybe a Mac OS, because you can get that too. So when you select down a list, whenever you're on the cloud instance of AWS, when you're on the dashboard, most people that are experienced or have certifications, like myself or others, will actually use the command line, the AWS command line, and we can configure these things using JSON request, whatever. But they do have a graphical interface. Now you see that we have this virtualized environment where one machine appears to be multiple operating systems, but inside of one of these operating systems, we can have what we refer to as containers. Now these containers are not a full-fledged operating system. So let's look at Ubuntu. Maybe this would be a better example. So inside of Ubuntu, that's the operating system running this on this hypervisor, one of the operating systems running on the computer's hypervisor. Inside of that operating system, we can have something called containers. Now, what containers do, sometimes you may hear them referred to as Docker images or Docker containers. What they do is they don't actually represent an operating system themselves. Because up here in the OS, you had Windows, Ubuntu, Red Hat, Amazon, Mac. All of these may be similar in some ways, but they are very different distributions, different operating systems with different code running on them. So what we have in Ubuntu is that all of these containers will effectively use this single Ubuntu's kernel, and it will pretend to create isolated environment, not pretend. It will actually create isolated environments just kind of using that shared Ubuntu kernel, right? So effectively what we could do here is each one of these is an isolated environment. And then this one's an isolated environment. So what we could do is if I have this student, maybe student 1, and then we have student 2, I can make student 1 appear like they've got terminal shell access to their own isolated Ubuntu or maybe similar instance. And then student 2 will appear that they've got their own instance where they could create users, they could run programs, and these two containers will make it look like they're on two separate computers, as though nothing is kind of like shared there. Now, there may be things you can look into it and realize that you're in a shared environment, but for the most part, you're basically acting like you're in your own computer. So just think about how complex this is. We have these containers, multiple containers running inside of one Linux distribution. This one Linux distribution is running along with other Linux distribution and Windows operating systems and Mac operating systems inside of one server inside of AWS. And then this server is among many inside of a rack, and that rack is among many racks inside of a data center. And you see, the world is very complicated, right? And a lot of these are through some really cool algorithms created by computer scientists, like what you're learning yourself, right? Okay, so that was the basic overview. I just wanted you to have some exposure. By the way, in the Windows environment, this is where you're configuring it. Sometimes you'll hear it called an EC2 instance. Whenever you create an operating system on one of these hypervisors that you configure that will spool up in just a matter of seconds, you call it an EC2 instance. Down here, you'll primarily maybe what we're going to call a Docker image for these containers. All right, so that's just a brief overview. Thank you for humoring me with that. Let's transition over now to the web browser where we're pretty much going to have. This is a view. I told everybody that we typically do not use the graphical interface when we spool things up, but Amazon does provide that if you want to have it. So if you look, this is effectively where I could configure an EC2 instance. So what I did, if I wanted to, if I wasn't using the command line, I could go over here and I could click Launch Instances, and I could maybe click this down. And then when I click Launch Instance, I would ask several questions about how many cores I want, how much memory I want it to have, whatever. And then once I click Create, it'll go through and in a matter of seconds create a subdivision at Nitro Hypervisor where it looks like a computer that's running, and I selected it to run Amazon Linux 2, right? So isn't that cool? And this is kind of the instance, this kind of pretend operating system that we got, not pretend, this virtualized operating system we have running on the Nitro Hypervisor. I gave it the name Coder Instance because that's what we're going to call this sandbox that we're creating. All right. Now, let me hop on over it. What you got, what I installed on that instance was a platform called Coder. Coder allows you to manage Docker images. Every student in the class, or every student that has reached out asking for one of these sandbox things, we effectively create a Docker image on that one Amazon Linux 2 operating system that's operating on a Nitro hypervisor that's in the US East 1 server, that's in the server in US East 1 AWS data center. So effectively what you've got is you've got your own container inside of this thing that I called the Coder instance at AWS. So in the email that you got, you'll see that you got an email. You're going to use your email address that I labeled in there. So all your credentials are listed, the email address that you should use, and your password. So when you log into it, you'll essentially use that information. So let's do that. I'm going to pretend like I'm going to put mine in here. And I created it just like I was a student. So let's see if I can remember the password. Okay, and then when you log in, you'll see something that looks just like this. This will be what it looks like, I think. Now, I don't know if this will actually be it. So what you first want to do is you want to click on Workspaces. Now, you don't have a workspace at all set up, all right? Nobody has a workspace set up starting out. Because maybe you want to create a workspace for your CSE 220 class. Maybe you want to create a workspace for your CSE 235 class, or maybe whatever class you got, or maybe you just want to have one for your personal. You can create a container yourself. So we've created a container where you can create your own containers, these isolated environments. So if you want to just get started, what you want to do is click this little box. You click the box, and what you're going to do is give it a name. So like I teach CSE 220, and sometimes students use this instance. I'm going to, maybe if I was a student, I would say this is going to be on my CSE 220 workspace. So I click Workspace. Look how fast this spools up. What used to take us an hour to install an operating system on a computer now takes us just seconds. And if you look, you see these little things spinning around. It looks like things are happening. There we go. This thing is completely running. We have just started up an isolated environment where you could pretend to be working on your own computer in just seconds. So you're all set. That's all you had to do. Now, how do you use this? Well, first of all, let's suppose that you want to get some training with the terminal. You click this. All right. So you have this running, and if you look, this is effectively a browser screen. But there is effectively no difference in the way it looks than if you were sitting at a terminal in front of a computer. That's what you say. So if I was on my Apple computer and I was to pull up a terminal, that is exactly the way it would look. And there's no latency really to speak of. I mean, I could sit here and type fast, whatever. I can do the list, I could make a directory. Let's suppose I want to say maybe my assignments. I'm going to create a folder for my assignments. Notice that it's there. I can go into the assignments. All of the tabs and all of these hotkeys and all these other things that you use in your terminal, all of those work just fine. Same as ever. Okay, now let's suppose that you're working on an assignment and you absolutely need to use GitHub. Well, it turns out that this is going to be even easier. This is going to be quite a bit easier, actually, because this means you don't even have to really generate SSH keys because it's already going to have one available for you. So what you want to do is click here and then click account, okay? Click here, and this is the SSH key that you would have to generate on your own computer. But since we made this environment for those of you guys that may be a little bit behind on getting your environment set up or your computer is crapped out and you don't want to like spend all this headache of getting git bash and everything else set up or these SSH keys, well, guess what? All you have to do is basically click this copy button. Then you go over to your GitHub account. This is my profile. What I will do is I will go here. I will click settings. I'll click SSH. I'll click new one. I'll put my CSE 220, maybe virtual instance, just to give it a name. It really doesn't matter. And then what I will do is I'll paste this here. By the way, I'm not worried about you guys seeing this key because by the time you're watching it, I will have all this deleted and I won't even have an account on there, so it's not a big deal. So now I'm going to click Add SSH Key. So if you look down here, I've actually got it. See, it's on there. Now what I can do is I can go over here. Let's suppose I'm in my Java class and here's the Hello World code demo that I did in class. I can actually click this down button, copy that, and now I can go back over here to my terminal and I could do this. I could do git clone, paste that in there, and say yes. And then all of a sudden, look at this, guys. I have got my entire setup from start to finish. What would take students sometimes maybe a day or so to really hum through and kind of get everything going, to generating the SSH key, figuring out how to make it work, then pasting it into GitHub. It's all so much easier now. So let's take a peek. If you look, you see where I got the Hello World. I could go inside of there. And if you're curious to make sure that it works, I'll actually edit that README file just so you can see it. So I could maybe insert. I'll put something here called silly addition. Then I will do git add stage of changes, git commit. Sorry, I cannot type. I'm having to type over the top of my tablet here. Sorry about that. Just random addition. And then I'll do git push. All right. Then watch what happens when I go over to my repository. Click code. And notice that the silly addition's there, right? Okay, well, some people don't like working off the terminal, so one of the other benefits of this instance is the fact that, oops, I've got one open here. I shouldn't have done that. Go over here to my workspaces. I'll click in my Docker image. And you see where it says code server? By the way, that was a lingering one that I had before. Sorry about that. I'll click code server and then watch what it brings up. Click open workspace. And you can just click OK if you want to here. And what I recommend you do is I personally hate that kind of like the bright screen. What you can do is you can go to File, Preferences. You can go down to the theme. Pick the color theme, and then what you want to do is default dark. All of a sudden, what you're looking at is this is effectively VS Code. It's identical to what you have. Now, there may be a few extensions that you can't download onto it, but for the vast majority of this will look perfectly fine. This is kind of essentially what you're going to use if you had your own laptop or whatever running it. So let's suppose that I just want to say I want to add this repository that I've just had for my class, so I could go add folder workspace. I know it's in the home directory. I know it's Coder is effectively what your users are going to be on this thing. And notice that assignments is where I was at, and then I'm going to click this hello world, and I'm going to click OK. That is effectively the repository that I brought in. Notice that it's opening up, that README file. When I click it, you see where I made that silly addition. Now I'm just going to delete that back, so that way you can see that I don't really want that anymore. Now, whenever I save that, notice what happened here at Git. Git is now, if I wanted to, since I've already got that SSH key and everything linked up, and it knows that this directory is already a Git repository, all I have to do is stage the change. If I don't want to use the terminal, I could add a message that says reverting back before silly update. I'm going to click commit. I'm going to click sync changes and say don't show again. And if you look, if I go back to my repository, let's see, where's that at? Go back to my repository, you'll be able to see that the commit message was reverting back before silly update, and I just took all that off. So as you can see, this basically provides an environment where you can basically have a terminal. You could even add users, whatever. Anytime you issue the command sudo, you don't have to type in a password because Coder is considered, it'll automatically do that for you. So if you need to do like sudo type privileges, you just type in sudo and then the command and it should run. You could even add users to this if you wanted to, this container, so you could have users inside of your container. The only thing that I ask is that whenever you get done is you do this. So we're effectively here running on this. Once you get done for the day, I would like for you to stop it. That's what I'd like for you guys to do. So that way we're not just wasting resources that may interfere with someone else, okay? Now, you can go back to workspaces. Let's suppose that we've got that. I want to create a new workspace. Maybe I could contain another one to where, like, instead of calling that, I would say CSE 220. So I could go create a new workspace, see all templates maybe, create workspace here. And I could say, what could we say? We could say maybe CSE 235. Then we create a workspace. Okay, now your CSE 235 is here. So whatever you needed to be inside of there, you've got that now. So we'll let it finish booting up here before we turn it off. Okay, so I always say we went to the terminal, we did code server, we did whatever. If you click this one, it's going to open up your local one. So unless you just have local one, I don't really know that you need to use this. This will just allow you to like work in both places, but for the most part, if you're using this, you probably want to use terminal or the VS Code version. So we could just stop this. Take a look at our workspaces. Now we got one for our CSE 220 class, we got one for our CSE 235 class, and everything is just great, right? We have a place where we could have it all managed. Let's suppose now that I really don't care anything about this instance anymore, maybe I could just click delete. And then to make sure I don't actually do it, I have to type this in, CSE 220, and I click delete. Now, what I am going to tell you guys is that if you leave an instance running for a long time, and I don't know about it, we may end up shutting those off, okay? So what I want you guys to know is that this is supposed to, you go into it and you back out of it. Don't leave things running if you don't mind, okay? So with that said, I'm just going to log out of the screen. And that's it. So basically, you have now your own Linux sandbox that you could play around with, learn all the things you need to, or if you need a configuration help, you've effectively got that. So if your computer craps out, or if you're struggling with a configuration, or you just want the ease of this, it's fine. Again, make sure you turn them off whenever you get done, because they will stay running if you don't. It's not a terrible thing, but keep in mind, we may have several hundred students using this, or we may have 50 students in a class using it, so let's be mindful of that. Be mindful that if you do leave one running, we may have to shut them off if resources become constrained or whatever. And please don't use this to run like highly parallelized computer code. You can run like small ones on there. Just, I don't even care how parallel the program is. Just try to avoid running things on there that's going to be running for like days at a time. There's no point in trying to do machine learning on this because this is such a weak instance, you're not going to get anywhere with it. So basically anything that you want to do GCC, you're good with. Anything that you want to run like a quick Python script with, you're good with. Anything that you need to install with yum install, you could do sudo yum install GCC if you need install. I don't know, it'll probably already come with it. Whatever you need, you can do. Just try not to let things run for long periods of time. Shut it off when you get done, and nothing that's going to be running for days or serving APIs. If you need something like that, come talk to me and do the 216. We'll see if we can configure something for you. But other than that, let's please not do that. All right. Well, thank you guys for your attention. Thank you for your time, and I appreciate your efforts in your class. And hopefully, this will be something that's useful to you.